Howdy folks, in this video we're going to be walking through a percent of total measure in DAX. Right? The goal of this is not to make the world's most bulletproof percent of total measure, but rather to take a very simple percent of total measure and see sort of how it's working at a mechanical level. So let's go ahead and do that. We start up here with some stuff. We've got a very simple data model over here on the right. We have these different sales here. We've got, I think, about 9 different sales transactions, right? Very small business, if you will, just small enough for our example. So we've got these 9 sales transactions, and the sales table is related via a one-to-many relationship to our product table. So for each sale, for each transaction, we know the product foreign key, which maps to the product primary key over here in our products table. So we know that this particular sale, P04, maps to P04 over here in our product table, which is to say a scone, or a scone, which is the type of food. Okay. So in addition, we've got a pivot table, or if you want to think of it as a matrix, if you were over in Power BI, you could think of it that way. And on this pivot table, we've got our products, our product names, more specifically here, on rows, and we've got this measure of M sale percent, which is to say it's a measure of the sales percentage for each one of these products. So we know that bagels made up 12% of sales, coffee made up 32%, lattes made up 32%, and scones made up 24%, all adding up to 100%. And over here, we've got the definition for that particular measure, right? And it's a pretty simple definition. We've got this divide sum of sales amount by the sum of sales amount for all products, okay? Now, if you can't look at this and immediately know how it works, hey, you're watching the right video. I'm going to show you how it works, okay? Before we get into that, though, I've got 2 notes. We've got the all function, which is going to let you get a copy of a table bypassing the current filter context, which is to say a non-filtered copy of the table. Usually when you get a copy of the table, it's filtered by the current filter context. If you wrap the whole reference, if you wrap the asking for it in all, you bypass that to get the entire thing. We've also got this divide function that we're using, and divide lets you divide, well, one number by another number. And so you might be asking yourself, why don't I just use my little forward slash and divide that way? The reason being is divide protects against 0 divisions, which is to say if the denominator is 0, if the thing you're dividing by is 0, rather than getting an error or infinity in the case of DAX, here you get a blank instead, which I think looks a lot nicer to end users. That's what that divide function does. Okay, with that knowledge, let's go ahead and get started, shall we? So I'm going to go ahead and give myself some additional white space here, just to make the code a little bit easier to write. Let me just zip back. That's what it looked like before. Here's what it looks like now. Same code, just easier to read, okay? So let's consider this cell right here, the percent of sales for coffee, 32%. How'd we get that number? Well, let's start by populating our cell's natural filter context, which is to say whenever you've got a cell or a point on a graph or anything like that, when the measure starts evaluating, there's a natural filter context. There's a filter context that gets populated automatically without having to use calculate to do it, right? So this gets populated by a lot of different things, such as whatever the current pivot table or matrix's row or column is, anything that's selected on slicers. If there's any report or page or visual level filters, those go into the natural filter context. And if there's any active cross-filtering engaged, so if there's like a pie chart somewhere else on the page and somebody's clicked on a slice to filter everything down to that slice gets added to the natural filter context. But here in this very simple world, we've just got this pivot table, and the only thing we actually have is on rows, here we've got coffee, so the name of coffee. So the only thing we actually care about is the current pivot table or matrix's row or column value. It's coffee right there. So we take coffee and we just dump that right into the natural filter context. If we had other stuff, we'd put that in the filter context. If there was something on columns, like say type, we would put that in the filter context. But right now, all we have is these values on rows. And so for this cell, it's just the name of coffee, product name of coffee. That's what goes in our natural filter context. So moving forward, we start evaluating our measure. So what we want to do is we want to divide this by this. Well, what divide's going to need is it's going to need a number here and a number here. So we need to go ahead and just start grabbing those numbers. And the first one we're going to start off with is the top one, the numerator, right? So this is going to be the sum of the sales amount. So Whenever you ask for a table explicitly, or you use a basic aggregation on one of its columns, like sum or min or max in this case, sum, a copy of that table gets expanded, bringing in any columns from the one side of a one-to-many relationship, and then that copy gets interjoined with each table in the current filter context. This is how you get the filtered view of the table. So you don't get, all the sales, you just get the sales for coffee, okay? So let's go watch that in action, right? So step one, a copy of that table gets expanded, bringing in any column from the one side of a one-to-many relationship. Well, we're going to get a copy of the sales table because we're summing up the sales amount, okay? And does the sales table have any tables on the one side of a one-to-many relationship with it? Well, yes it does. This product table is on the one side of a one-to-many relationship. So we're going to go ahead and expand the sales table to include all these columns. What does that look like? Well, it looks something like this, right? Here's the one-to-many relationship. That's what's going to cause this expansion to happen, okay? And we say, all right, for the first row here in sales, the product foreign key is P01. Well, that maps to product primary key up here in the products table. So I'm going to go ahead and get this row and just stick it right down there. Just like that. Boom, stick that right there. Cool, move on to the next row of the sales table. P04, well, that maps to P04 right there, so I get this row and stick it right there, right? Then, next row, P04, same deal. P04, I go get that row and stick it right there. And I keep going on down, right? For each single one, I say, all right, I use that relationship to go get all the values from the column in the product table, right? So essentially on my sales table, not only do I have my sales columns, I also have my product columns. That's what the relationship is going to do for me, okay? All right, all done. We've gone ahead and expanded the sales table, right? This is an expanded copy of the sales table. The blue part was just the sales table with its sort of regular columns. These green columns are the expanded columns. This is the expanded copy of the sales table. It's not the filtered copy yet. We're going to do that in a second. Right now, it's just the expanded part. Okay, so now that we've got this expanded copy, we're now going to interjoin it with each table in the current filter context, which happens to be the natural filter context, because we haven't used calculate to modify it yet. So I'm just going to move this over to the right, just so it's a little closer to the table we're filtering on, right? And we say, okay, we take this table right here, and we interjoin it with each table in our current filter context. Well, there's only one table in the current filter context, and it's this one row, one column table with the column of name and the value of coffee. Well, over here in the table that we're going to filter on, there's a column for name, right? So we're going to filter this column, but with this. And technically we're interjoining, but the behavior is going to be like a filter, okay? So over here we've got name of coffee. Those are the values that are allowed. Well, let's go find all the coffee values. Okay, those are the rows that we're going to go ahead and keep. That's what the interjoin is going to do. So we go ahead and get rid of the other rows, and we just keep the coffee rows. Okay, cool. If there was another table in the current filter context, we'd interjoin with that one too, but right now there's just the one table. So we're actually good and done, okay? And so now, this is going to be the filtered view of the table. Or said otherwise, this is the view of the sales table in the current filter context, right? So for this cell, if you don't use calculate to create a new filter context, you stick with the natural one, the sales table looks like this, right? So when we sum up the sales amount, we don't sum up this column over here, we sum up this column over here, right? So we're always working with views, or with copies, okay? So, sure enough, just going to go ahead and sum up that column right there. So the sum of that sales amount is 8, which is what this bit of the code right here is going to evaluate to. This whole thing is going to turn into 8. So let's just go ahead and stick this down here so we can remember it, right? So the numerator for my divide function is going to be 8. Cool. Let's move on to, just stick that back where it belongs, right? Put it back in its home. Now let's move on to the denominator, right? So we have the numerator, now we do the denominator. So for the denominator, we're also going to take the sum of the sales amount, but we're not going to use the natural filter context. We're going to overwrite that. We're going to create a new copy of it that's modified. So we're going to get the sum of the sales amount under a different view of the model. And the different view is going to be based on this all products. We're going to get sum of sales for all products. So let's watch how that happens mechanically. Okay? So first thing we're going to do is get all product. Remember back here to our notes, all lets us get a copy of a table bypassing the current filter context, which is to say a non-filtered copy. Oh, hold on, my trackball is giving me, there we go. So normally if we were to ask for the product table, we would get the product table, but filtered to name equals coffee, right? Based on this table in the current filter context. Well, what I was going to do is it's sort of like just going to turn it off for just a second, just long enough to go get a copy and not have to have it be filtered by anything. So we get the entire thing. Boom. Okay, that was easy. All right. Let's just stick that down there. Okay, so now that we've got the all product table, all of the products, Calculate's going to go ahead and create a new filter context, right, based on that all products. So we take the current filter context, which happens to be the natural filter context. We make a copy of it, okay? Let's give ourselves a little more room here, right? Oh, I'm sorry. So we've got this copy of the natural filter context, and so how are we going to change it? What's our as if? What's our set filter argument? How is this thing going to? How is the copy going to be different than the old one? Well, it's just going to be as if we're looking at these products right here. So that all products, that becomes our as if. That's how we're going to modify the filter context, okay? Now we can go ahead and give ourselves some room. And if you'll notice in the filter context that we're going to build, currently there's this name of coffee already in there. But over here in our as if table or our set filter table, there's also a name. And it's got coffee, latte, bagel, scone. Well, so this raises an interesting question. Which one of these is correct? And the rule of thumb is when you're using Calculate, if there's a column in your as if or your set filter argument, and that column already exists in the previous filter context, the one you're about to overwrite, it just goes away, right? So we're just going to get rid of this right here to make room for the column here in this table. So we're just going to make that go away. Cool. And now we could just take this and just drop it right in there. Boom. And like that. Okay. Now we've got an altered filter context, and this becomes our current filter context for the purposes of argument 1 of Calculate, okay? So what Calculate did is it built this new filter context expressly so that it could evaluate argument 1 of Calculate inside of it, so we can get the sum of the sales amount in a new view of the model, right? More specifically, a view of everything, of all products. That's what we were going for. Okay, so let's go ahead and take the sum of the sales amount. We remember our rules down here. When you ask for a table explicitly or use a basic aggregation of one of its columns, sum, min, max, etc. In this case, we're doing sum. You start by getting a copy of that table, which gets expanded, bringing in any columns from the one side of a one-to-many relationship. Well, then you interjoin that table with each table in the current filter context. This should sound kind of familiar. Okay, there's that relationship again. So when we get a copy of the sales table, we go ahead and expand it. I'm not going to go through all the steps. I think you sort of got the idea of how that worked. Cool, now we've got our expanded copy of the sales table. We got to filter it, okay? So we say, let's take this and interjoin it with every table in the current filter context. Well, this is the current filter context. This was the current filter context, but Calculate said, nope, we've got a new one that we're going to use. So let's take this one table and interjoin it with this one over here. Okay? We're going to interjoin it. So if you'll notice on this table, it's got columns of type, name, and product primary key, which are the same columns that are over here in our table in the filter context. Type, name, and product primary key. This is the reason why that expansion was necessary. If we didn't expand the way we did a second ago, our filters here on type, name, and product primary key wouldn't actually affect the sales table, right? That's why we expand. Okay, so here's the different sort of rows that are allowed, right? And it happens to be everything, which is sort of what you would expect, because the entire idea for this sum of sales amount is that we want to do it for all products. So previously we had a filter of coffee. We're essentially overriding that filter and any other filters that occur on products. We want to bring in everything, and if you'll notice, this is what we get, is everything, okay? So now that we're done, this is our new filtered view of the table. This is the view of the table inside argument 1 of Calculate here, okay? Right? This is the view of the sales table in the current filter context. This filter context right here, which was built by Calculate for evaluating this expression right here. So when we get the sum of sales amount right here, we're getting it for this column, right? Sure enough, we sum that up, we get 25, right? And this becomes our denominator. So let's put the denominator, that value, right down there. Okay, that's pretty easy. Well, that's all the hard stuff. Now all we have to do is say, well, let's take, we're going to divide the numerator by the denominator. And if you're not a math major, that's okay. I've done the work for you. The number 8 divided by 25, well, that's pretty simple. That's just 32%, right? Simple as that. And that is how we get that number right there. Now, I should say, before we do anything else, we're going to, I should say, let's step back a second. I just wanted to mention something. I kind of jumped through this kind of fast. When we got this 25 here for the denominator and we put the value over here, When we're done with that, we built this altered filter context, right, for the purposes of this argument right here. When we're done with that, when calculate's finished, the filter context sets back the way it was before, right? So if we move forward, this once again becomes the current filter context for everything outside of that argument right there, okay? Sorry about that. Okay, so we go ahead, we take 8, we divide it by 25, we get 32%, and sure enough, that's our number right there. So that's how we get this percentage right here. So let's walk through one more, right? And we're going to do it a little bit faster, but I think you sort of get the idea. Let's go look at this scone and see where we get the 24%. Okay, let's just sort of start by saying, well, what's the natural filter context for this cell? Well, there's no slicers because they don't exist on this page. There's no reporter page or visual level filters. They don't exist on this page. There's no cross filtering. The only thing there is on rows is this value right here of scone, of name scone, right? That guy right there. So we're going to take that and we're just going to stick it right in the natural filter context. And I've already done that, okay? So the natural filter context has one table in it. It's a one column, one row table of name of scone, right? That's the value that's allowed. Okay, so if we take that natural filter context and we get our numerator, the sum of the sales amount, well, it's not the sum of this sales amount, right? It's the sum of this sales amount that right here, right? Actually, I'm not quite done yet. We took the sales table and we expanded it, and we said, nope, we only want to keep the scones. In fact, oops, this is wrong. Here, let me fix this real quick so you guys can see this being done live. So we're going to coffee. We only want to keep scones. Just get my coloring right. Make sure I got that right. Alt-H font color, automatic. Hey, there we go. Sorry about that. I was experiencing some technical difficulties. So let's see if we filter down correctly. I think we do. Boom. There we go. Okay. Hey, how about that? Did it live. Okay, so let me just look at that again. So we took our expanded version of the sales table, and we're going to filter down to just name of scone, and well, there's name, and those are the scone values. So we're just going to keep those two rows right there. Boom, just like that, okay? And if we sum up that column, we get 6. That becomes our numerator, right? As you might guess, the denominator is going to be the same darn thing because that all products is going to overwrite everything. But just to show you that that is indeed the case, if we move on to the denominator, well, the denominator says let's get the sum of the sales amount, but let's start by creating a new filter context, and we're going to take the old filter context, make a copy of it, and we're gonna modify it with this as if right here. And the as if is all products, right? So the name of scone gets overwritten and it gets replaced with this whole big table right here. So this becomes the current filter context. When we go and we take our sales table, we expand it and we filter this with this. And if you'll notice, this right here has got all the products in it. So when we filter this table with this table, and by filter I mean inner join, we end up bringing everything back, which is exactly what you want because we want sales for everything. That's the entire idea behind calculate sales for all products. That's the intuition behind it, okay? So the filter sort of doesn't really do anything. And then when we sum up the sales amount, we get 25. So that becomes our denominator. So now we've got 6 divided by 25, and that's 24%. And sure enough, there's our 24% right there. So let's go look at one last one. Okay, let's look at the grand total of 100%, right? So as you would expect, all of those numbers should add up to 100%. So let's see how that actually works. So what's the natural filter context for this cell right here? Well, in these, like for this one, it had coffee in it, and for this one, it had scone in it. This one doesn't seem to have anything in it, and that's correct. The natural filter context here for the grand total is completely empty. If there were slicers somewhere else on the page, if there was cross-filtering somewhere else on the page, it might have those values in it. But because this is a very simple model, we've got a grand total here, and it's, there's no values on rows, there's no values on columns. We start with a completely empty natural filter context. Okay, so we get a copy of the sales table to get our numerator up here, our sum of sales amount. We get the sales table, we expand it, and then we interjoin that. With everything in the natural filter context, except there's nothing in the natural filter context. So when we try and interjoin it, there's nothing to do. So we end up with the entire sales table. And we've taken the sum of the entire sales table, sales amount, we get $25, okay? And now, if we move on to the denominator, we actually get the same result, but we get it through a different method, okay? So calculate's going to say, all right, take the natural filter context and modify it, and we're going to modify it with this all products, right? So we've got our blank natural filter context, our natural filter context with nothing in it. Override it with this. So we take the empty thing, we just dump this right in there. Okay. Then we say, all right, let's get our sales table. We expand it, and now we interjoin this table with this table, acting as a filter. And what's interesting is this is all products. So even though we're filtering this, we're essentially creating a filter that brings everything back. So we're saying, hey, you're only allowed to bring in certain products. Oh, really? Which ones? All of them, okay? So we are filtering it, but the filter has no effect because our list of things that we're going to be allowed is everything, okay? So now we say we sum up the sales amount of this table right here, and we get $25. That becomes our denominator, okay? And now we just take, well, fix this, sorry. I've got all sorts of problems here today. 25, 25, 100. So now we take 25 divided by 25, we get 100%, and that's how we get 100% up there. So, that's sort of, it's actually not too tricky. I do want to mention one thing before we go, though. If we sort of rewind for a second, all the way back to this slide right here, if we're looking at the scones percentage, right? If we come down to this bit where we're going to take the sum of the sales amount for all products, if you'll remember, we took our natural filter context, we got our all products, and we overwrote the natural with this table right here, and we ended up with this right here, right, where we've got all the products in our current filter context, and we ended up bringing everything in, right? We filtered, but it didn't do anything. So you might be asking yourself, what's the point of filtering by a table in which that table has all of the potential values you could have in it? Which is to say, what's the point of having a list of things that are allowed if everything is on that list? Isn't this the same thing as just not having anything in the filter context? And you'd be absolutely correct. And in fact, there's actually an optimization in the DAX engine such that if you use all inside of one of these as if or set filter arguments of calculate, which is to say any argument except for the first one, you can think of it as bringing back the whole table and making it look like this. In point of fact, what it actually does is it wipes out all the filters on any columns in product. That's the behavior of it. Now, the outcome is exactly the same, right? Because if we look back, let's go back one step. Here we filtered by this table, but the filter didn't do anything because it brought in everything. Here we don't filter at all, and we still get everything, right? So the outcome is exactly the same. The only difference is the engine didn't have to go through that extra step of interjoining on this table, right? So this behaves just a little bit faster, okay? So this is a special behavior of the all function, and it only occurs when all is used in a set filter or an as-if argument to calculate. The idea is filtering by a list of products that includes all the products is the same thing as not filtering on products at all. So some folks think that it's easier to remember it as clearing filters, like I've got right here. Other folks think that it's easier to remember as bringing back a table of all of the different products, right? Other than very advanced DAX, it actually doesn't matter which way you think about it. So whichever one is easier for you to remember, go ahead and memorize it that way. I happen to think that if you're starting out, this one's a little bit easier, right? Because if you use the all function in other places, the behavior will be exactly the same. But if you're sort of the technical sort of person and you want to know exactly how things work, well, it's a bit more like this, okay? And that's it. That's all there is to know about a very basic percent of total measure. I do hope that was helpful, and I will see you next video.